Hi, welcome to ACE Online. Myself Krishna Reddy, faculty of ACE Engineering Academy of Electrical Department. So, I am going to deal power systems subject. Okay. Now, in this session we are going to discuss, so what is the preparation strategy for power system subject? Let us go in details. So, if we observe GATE, ESE and all competitive examinations, power systems plays an important role because this is one of the main core branch. In GATE electrical as well as engineering services electrical examination, this forms a crucial role. Okay. So, now let us observe here what is the weightage of this power system subject in GATE electrical engineering as well as engineering services examination. So, in 2017 two sets, set 1 and set 2, 1 mark questions they appeared 2 mark questions there were 4. In set 2 1 mark questions 3, 2 marks questions 3. 2018 onwards 1 mark questions are 4, 2 mark questions are 4. 2019 also same. In 20 1 mark questions are 3, 2 mark questions are 4. In 2021 1 mark questions are 3, 2 mark questions are 4. 22 GATE 1 mark questions 4, 2 mark questions are 2. So, in coming to the engineering services, each question carries 2 marks. So, 12 questions in 2017, 18 in 2018 there are 19 questions and 19 onwards there are 12 questions that are being asked. Okay. So, from this we can say that the power systems is a crucial subject either with GATE or ESE or any public sector unit examinations like Transco, Genco, all this. Okay. Now, which books are to be referred for preparing for GATE or ESE or PSUs? So, generally there are two good books that are to be referred. One is Electrical Power Systems by C.L. Wadhwa. This is one of the Bible we can say, and the other one is Power Systems Engineering by Nagrat and Kotari. Okay. These two books are sufficient with respect to these examinations GATE or ESE or PSUs. Okay. Now, let us see here what are the topics that are to be covered with respect to power systems from GATE and engineering services examinations. So, mainly power systems, if you observe in power systems, if we observe, majority of the questions are coming from faults, stability. These two are the main areas, and load flow studies. So, this is one of the important area where the questions are frequently asked. Apart from this, one more important area comes is transmission and distribution. Transmission and distribution, that is nothing but T and D. So, definitely we can expect a question from transmission and distribution, that is power transfer equations, all those. Apart from this, the another area where the questions are asked is my topic, that is protection, power system protection, economic load dispatch, economic load dispatch and load frequency control, load frequency control. So, coming to the power system protection, economic load dispatch and load frequency control. So, here what you should read, okay, what you should read, relevant syllabus to the examination you need to follow, what you should read. Okay. So, if you observe the power system subject, it is very lengthy. So you cannot go in deeper in all aspects. So what is a syllabus? Syllabus should be in your hand, okay. So topics that are specified in the syllabus are to be thoroughly studied, okay, relevant to the examination. Concepts are to be understood clearly, and as per the GATE or ESC, if you concern, numericals are to be practiced. So there are three rules for getting a good rank in any examination. Is first rule is practice, second rule is practice, third rule is also practice. A practice is the one which leads to success. So you should have patience to solve more number of numericals for achieving your success in examination, okay. And so as the time is a constraint, shortcuts are to be derived from the lengthier solution procedure. So if there are any shortcuts, you should have them in hands, because time is a constraint here. The same paper given for 1 day solution you can easily solve, but within a time bound of 3 hours if you want to solve, then shortcuts are to be in hand. And you should follow or practice more number of tests that are provided by our institute, okay. Practice tests are being provided, so you should go through the online tests and practice them more, so that you will have a good confidence in examination, okay. Now what way you should make this? So go through the class notes. So as the faculty are providing a class notes, that will give the basic idea about the entire subject, that will be the building block we can say, and material is also being provided by us. Apart from the classroom notes and material solved problems, you should compulsorily practice the previous GATE questions. You should go through what? Previous GATE questions. So which will build your confidence. What I can say is, by solving the previous GATE questions, you can have a good confidence, or which model questions are being asked, okay, previous GATE questions and previous ESC questions also, okay. So these previous questions will build up your confidence, what type of questions are being asked, what you should read and what you should avoid. So that will be giving the idea from this previous GATE and previous IES questions, okay. Once the topic is completed, you should solve previous GATE questions from that topic and previous ESC questions from that topic. Apart from that, our academy is providing your additional bits and bytes. So there are good number of questions in that volume, and after getting through all this, you should prepare a short notes, because there are more number of subjects that are to be revised at the end. That making a short notes will help you a lot to revise fast, okay. So these are some of the approaches that you need to do for achieving your success in examination. Now coming to the power system protection part. Power system protection part. Here in protection, mainly we will be studying about what relays, circuit breakers. Apart from that, if you are going for ESC, you need to study about fuses, lightning arresters and over voltage protection in extra when compared to what this relays and circuit breakers, okay. And load frequency control, in coming to the load frequency control subject, in load frequency control, that load sharing, how the load sharing is to be done when regulation constants are specified, that is one of the area where the numericals are asked. And definitely one question will come from economic load dispatch. So from economic load dispatch, definitely you will get one question. So there are two different classifications in economic load dispatch, that is providing the solution. One is neglecting the transmission line loss, how do you optimally schedule the thermal power plants. And in the second case, what you need to do? Considering the transmission line loss, how do you optimally schedule? Apart from these two, one special case will arise when transmission line losses are considered but not coordinated. So, these three cases, if you can analyze clearly, you can solve the problem from economic load dispatch. I can definitely say that one question will be from economic load dispatch. Okay. So, now let us look some of the areas. Okay. So, what I am saying here, power system protection part. In protection, you need to study about relays and circuit breakers. Okay. So, the calculations that are to be done in case of circuit breaker, and in relays also PSM calculation, TSM calculation, and in alternator protection, how much percentage of winding is to be protected, all these are what important topics. In circuit breakers, how do you calculate the active recovery voltage, and how do you calculate the rate of rise of restriking voltage when they are maximum. All these calculations in circuit breaker are also important. Coming to the gate, fuse, lightning arrestor are not so important, but going for ESC examination, you need to study them also. Okay. And economic load dispatch, economic load dispatch. Here you will observe three cases. From these three cases, definitely one question will come. One is, how do you optimal scheduling when transmission line losses are neglected. So, there are three special cases. If you can find the solution for these three, the one question will be in your hand. Optimal scheduling when transmission line losses are neglected. So, when you neglect the transmission line loss, how do you schedule the thermal power plants? That is one. And optimal scheduling when transmission line loss considered, and coordinated. And one special case arises when the transmission line losses are considered but not coordinated. In that case, you should not involve in the coordinate equation. These three are the areas where the question can be asked in economic load dispatch. Apart from this, the other one is load frequency control. Load frequency control. So, in load frequency control, what is the frequency deviation? That is one area where the problem is asked and expected question will be there. And the other one is the regulation constants of the machines operating in parallel will be given. He will say that frequency is dropped by so and so. So, what is the load sharing? Okay, that type of problems are asked in load frequency control. Now, let us look at some of the model questions that are asked. Very easy topic, that is protection, economic load dispatch and load frequency control. So, very easy questions, okay, directly you can answer. Okay. Just have a revision once or twice, so that will be benefit for you. So, now let us observe this question. Buckles relay is used for, where do you use the Buckles relay? In transformer protection. In class we will discuss now. Buckles relay is used in transformer protection for internal faults or external faults? For internal faults only. So, Buckles relay is used for protection of transformer against internal faults. Option B, external faults. Option B, C is both internal and external, and protection of induction motor. Okay. So, which one is the right one? Buckles relay is used for protection of transformer against internal faults. Okay. Now, let us observe this question. So, if a fault current of 2000 amperes, the relay setting is 50%, CT ratio is 400 by 5, is asking to calculate the plug setting multiplier. This is one of the important area where the question is frequently asking. So here he is asking to calculate the plug setting multiplier. PSM is equal to what? Fault current by CT ratio multiplied with what? Relay pickup value. So here if you observe the question, he has given the fault current as 2000 amperes, 2000, CT ratio 400 by 5, 400 by 5 multiplied with relay pickup value. Here relay setting given as how much? 50% it is given, 50 by 100 into rating of relay coil is not given. By default rating of CT secondary will be the rating of relay coil. Okay. So here if you can simplify this 200 and this will get cancelled out, this and this will get cancelled out, this 5 gets cancelled out here, and 5 ones 5 20s 4 5s 5 2s 10. So PSM is how much here? 10. So if you direct simplification will give the marks. Okay, PSM calculation is very important. So plug setting multiplier is how much? 10. So this type of questions are frequently asked, PSM calculation. Okay. Now let us observe here. This is a question from distance protection. Okay. Reactance relay is normally preferred for protection against. Where do you use the reactance relay? In reactance relay we have discussed in class. So that operation of reactance relay is independent of resistance phasor. Operation of reactance relay is independent of resistance phasor. That is why it is preferred to use earth fault protection. Reactance relay is used in earth fault protection. Now let us observe this question. In inverse definite minimum time electromagnetic type overcurrent relay, the minimum time future is achieved by. How do you achieve the minimum time future here? How the minimum time future is achieved? Observe the characteristics. Simple, sir. So basic theory that we discuss in class will be useful here. So in case of IDMT, up to saturation point, you will get inverse characteristic. Time of operation is inversely proportional to fault current. Beyond saturation, time of operation is constant. So it is becoming definite here. It is becoming definite. So how the definite time characteristic is achieved here? By considering the concept of saturation of CT core. Okay, that is nothing but the saturation of magnetic circuit is the basis for inverse definite minimum time relay. Okay. Now let us observe this question. This question in a 3-step distance protection, the reach of 3 zones of a relay from the beginning of the first line is typically extended up to. So if you go for the analysis of zonal protection scheme in a 3-step protection, so there are 3 sections he has said. So relay is placed here. So first zone will be up to 80% of the first line, 80% of the first line. This corresponds to zone 1. Zone 2 will be extended up to 50% of the second line, 50% of second line. This comes under zone 2, and zone 3 is extended up to 20% of the third line. This is zone 3. So look at the options. This we will regularly discuss in class. Okay, 80% of the first line, 50% of the second line, and 20% of the third line. Now here this problem was given based on relay coordination. He is saying that we need to identify the timings of relay 1 and relay 2 in zone 2. He has given this diagram and he is asking to identify the timing. Simple logic here, identify there is an overlap area between zone 2 of R1 as well as zone 2 of R2. So in this area if there is a short circuit fault, R2 relay has to operate first because it is in the section of R2. R2 relay has to operate first. So time of operation of R2 should be less than time of operation of R1. That is a simple in zone 2, in zone 2. So, observe here which will satisfy time of operation of R2 should be less than time of operation of R1. Option A will be satisfied. Okay, simple logic, there is no any calculation required for these type of problems that are asking in examination. So, now observe here transmission line distance protection, this is a question from distance protection. Relay having the property of inherently directional. Which relay is inherently directional? So, we have three relays, impedance relay, reactance relay and Moore relay. Out of these three relays, only the relay which is inherently directional is nothing but Moore relay. Moore relay is inherently a directional relay. Okay. Now, let us observe the next question. These sort of questions directly can be attempted if you have a concept in your hand. There is no need to go for any analysis, big analysis is not required from this protection and economic load dispatch and load frequency control. Okay, simple analysis is required. A negative sequence relay commonly used to protect. Where do you use negative sequence relay? In alternator protection, from protecting the alternator from unbalanced loading, we will be using this negative sequence relay. So, alternator protection will use a negative sequence relay. Now, let us observe, this is one of the important or model we can say generally asked in examination. So, let us read out this question first. A power system with two generators shown in the figure below, and he is saying that it is protected by 6 relays, mix of directional and non-directional elements. So, remote backup for R4 he is asking. So, if R4 fails to operate, remote backup is provided by. So, near to the source are what? Non-directional. So, we have identified that R1, R3, R6 are non-directional, R2 is directional, R4 is directional and R5 is also directional. Now, when the R4 has to be operated, suppose if there is a short circuit fault here, then R4 has to operate. Now, observe the path for fault current here. This is one path and this source will deliver in this path. So, which relays are sensing? R4 is sensing, R1 will sense, R6 will sense and R4 will sense. That means, if R4 fails to operate, then backup is to be provided by R1 and R6. That means, if R4 fails to operate, R1 and R6 are to be operated. So, option is D, okay, R1, R6. Okay, directly based on your practice, you can directly look at the answer, but practice is required for answering these type of questions. The most commonly used relay for protection of alternator against loss of excitation. So, he is saying loss of excitation. So, when the excitation is lost, mechanical input is present, then the machine behaves as induction generator. How do you protect the alternator from loss of excitation? We will be using an offset Moore relay. Offset Moore relay is used for protection of alternator against loss of excitation. So, now let us observe one more question here based on identification. So, here this model is also generally asked. So, where the directional relays are to be placed and where the non-directional relays are to be placed. So, that we will discuss in detail in class. Okay, relays at the source end are what? Non-directional. Here also non-directional. This for this load bus, this bus will act as a source. That is why this fifth bus is also non-directional. Double-sided arrow means non-directional. But relay 2 is directional, relay 3 is also directional. So, here what is asking discrimination? Directional overcurrent relays will be required. So, where are the directional overcurrent relays? Second and third. So, at second position and third position, you require the directional overcurrent relays. Simple questions, okay. Just we need to have the concept. Now, let us observe here. This is a question that was asked based on the protection of alternator. The neutral of 10 MVA 11 kV alternator is earthed through a resistance of 5 ohms. Earth fault relay is said to operate at 0.75 ampere. CT ratio is 1000/5. how much percentage of winding is protected. Generally, due to resistance grounding of neutral, certain portion of the stator winding is left unprotected. So, first let us try to get percentage winding unprotected. So, what is the percentage winding unprotected relation? Is equal to relay pickup value multiplied with neutral resistance that is grounded by V phase into 100. So, this relay pickup value is to be transferred to primary side. So, how do you transfer that? That is 0.75 given into 1000 by 5. Neutral resistance that is grounded is given as 5 ohms. Voltage is 11 kV, that is phase voltage, 11 into 10 power 3 by root 3 multiplied with 100. So, this gives a percentage winding unprotected, that is nothing but 11.8%. This is unprotected. But here he is asking what is the percentage winding that is protected, he is asking. So, 88.2% is being protected. This sort of some relations, short relations are to be kept in mind while you are solving this type of problems. Okay. Now, let us observe this question. The plug setting of a negative sequence relay is 0.2 amperes. The CT ratio is 5:1, minimum value of line to line fault current. This is the application of fault analysis to the protection subject. Okay. So, now here IR2 minimum primary side minimum negative sequence current required is how much? There is 0.2 into CT ratio given 5/1. This is 1 ampere. But he is not asking minimum negative sequence current. What is asking? Minimum value of line to line fault current. So, for line to line fault current, we know that it is root 3 times of IR2. So, IF minimum is nothing but root 3 times of IR2 minimum. So, this is root 3 into IR2 minimum is 1. So, this is root 3, that is nothing but 1.732 amperes. So, minimum line to line fault current is 1.732 amperes. Okay. Now, so with this I will conclude. I have gone through some of the questions that are given in previous examination for building up your confidence. So, very short questions, okay, very easy that we have solved just now, you have observed. So, just we need to have the practice and what are the formulae that we have discussed in the class. You should have a short notes, okay, that will helpful for you. Okay. Thank you for giving me this opportunity. Okay. So, myself Krishna Reddy.